Welcome back to another training video using the UK Electrical Simulator. In this video, we're going to wrap up the radial circuit series, at least for now, by looking at an immersion heater circuit. We'll look at the different heater ratings, the expected current draw, the protective device, the cable size, and the importance of local isolation. Like other fixed high current appliances, an immersion heater is normally supplied by its own dedicated radial circuit. It is not usually as demanding as a cooker or electric shower circuit, but it still needs to be designed correctly. We can view a few different immersion heater ratings in the ratings table, found in the Resources drop-down menu. You can see that smaller rated units may sometimes be connected through a fused connection unit, if the manufacturer permits it. However, for a typical immersion heater, it is usually more appropriate to use a dedicated circuit with a local double-pole isolator, such as a 20 amp or 25 amp switch, depending on the load. For many domestic immersion heater circuits, 2.5mm squared 2-core and CPC cable is commonly used. But as the heater rating increases, a larger cable such as 4mm may be required to handle the additional current and keep the voltage drop within acceptable limits. The protective device for an immersion heater is usually lower rated than those used for cookers or showers. Depending on the heater rating and the circuit design, you will more than likely see a 16, a 20, or even a 25 amp RCBO or MCB. As with all circuits, the final design must be supported by proper checks, including installation method, cable length, voltage drop, derating, and the manufacturer's instructions. So let's take that theory and see it working in the simulator. On the workspace, we have a C3 bus protected by a 16 amp RCBO, a 20 amp double pole immersion isolator switch, and an immersion heater. We are feeding the isolator from the consumer unit using 30 meters of 2.5mm squared cable, with a short half-meter connection from the isolator to the heater. After energizing C3, we can see the heater drawing around 4.35 amps. Even though a small 1 kilowatt immersion heater only draws a low current, that does not automatically mean it should be fitted with a 13 amp plug and plugged into a normal socket outlet. The current may be low, but an immersion heater is usually a fixed heating load, not a portable appliance. When it is switched on, it can draw its rated current continuously for a long period while heating the water, so the method of connection needs to be suitable for that type of use. For that reason, immersion heaters are normally treated as fixed appliances and connected using a proper fixed wiring arrangement with suitable local double pole isolation. For typical cylinder immersion heaters, especially those fitted to storage vessels over 15 litres, the expected arrangement is a dedicated radial circuit rather than a plug and socket connection. Smaller point-of-use water heaters may be different if the manufacturer specifically allows connection through a 13 amp FCU. But the key point is this: low current alone does not decide the connection method. You must also consider the appliance type, how long it will run, the storage size, isolation requirements, and the manufacturer's instructions. Now let's isolate C3 and change the heater to a 2 kilowatt model. As shown in the rating table, the current now increases to around 8.7 amps. That is still a relatively modest load, and the guide still suggests either a 13 amp FCU or a 16 amp protective device, depending on the installation and manufacturer's requirements. Next, isolate C3 again and change the heater to the standard 3 kilowatt model. This time the current rises to around 13.04 amps. For this size of immersion heater, a 16 amp or 20 amp protective device is commonly used, again depending on the circuit design. Now let's isolate C3 and change to the higher rated 4.5 kilowatt heater. Once energized, we can clearly see the current draw is shown in red at around 19.57 amps. That is several amps above the rating of the existing 16 amp RCBO. If we open the sim log from the Help drop-down menu, we can see the thermal trip countdown has started. In a real installation, this type of overload may take several minutes to trip. In the simulator, we shorten that time for training purposes, so the trip happens in less than 60 seconds, and even faster as the overload increases. Once the RCBO has tripped, isolate C3 and replace the protective device with a 20 amp RCBO. Then energize the circuit again. This time the current draw of around 19.57 amps is shown in green, meaning the load is now within the rating of the protective device. However, we still need to check the cable. When we run the voltage drop test, we see a value of around 8 volts. If we open the information panel, the simulator advises that we should be using 4mm squared cable, which matches the recommendation in the immersion heater rating table. This is an important point. Even if the voltage drop test technically shows a pass, we should still check the current carrying capacity and follow the rating guide or manufacturer's instructions. Voltage drop is only one part of the design, so let's isolate C3, change the cable size to 4mm squared, and run the test again. This time the voltage drop is lower, at around 5.5 volts, giving us a better and more suitable design for the higher rated heater. I hope you've enjoyed this video looking at an immersion heater circuit and how to design a more suitable circuit using the power rating guide, the protective device rating, the cable size and the actual current draw shown in the simulator. Please like, subscribe and leave a comment below.